Hello. Before moving to the actual demonstration, I just wanted to uh, let you know, Professor, that I already tried streaming with Apache-beam, but that didn't work in Collab. Actually, what I did is I used Coinbase API and subscribed. I mean, and using a WebSocket, I subscribed to its channel, and I got lots and lots of data. But I started, when I was executing this, I got some other cells output as the cell output. When I ran some cells, instead of the cell output, I got the data because the data flow is so huge uh, that the simple data queue could not accumulate all of the data, and data has been overflown as we are not using something like Apache, Kafka, or Google PubSub. Uh, I couldn't handle lots of data. So there was some issue with uh, yes, there was some issue with Pardo, the stream.q function. So what it does is it yields all the data from the queue into the pipeline, but the data flow was so huge, the cells weren't executing properly. So the Pardo function couldn't read the data into the pipeline. And as a result, I used to get this error, attribute error p begin has no windowing. Actually, the data is not coming, so the market data collection object is not, the collection object doesn't have any data. So it references to p begin instead of p collection. So I always get this error. So that's why I have used batch processing instead of stream processing. Now I'll show the demo of batch processing. Hello. Now I'm going to demonstrate my Apache Beam project where I took a dataset from UCI machine learning repository, a bike sharing dataset. So it has different attributes like seasonal and weather information, and we need to predict the count of bike rentals between the years 2011 and 12. So we start by installing the required dependencies, Apache-beam, scikit-learn, which is used for machine learning, joblib for saving and loading the model, Boto3 for interacting with AWS, as I will be uploading the predicted file to S3 for further analysis if required, and scikit-learn for machine learning models. So as we are done installing, next we get the dataset from UCI machine learning library, and I have unzipped it. And then we just read the structure of the data, all the columns, and then AWS credentials. Since we need to upload the predictions to Amazon S3, we set the AWS credentials like access key, secret key, and region. I've stored them in the Collab user data module. Secrets manager. Yeah, you can see I've stored here so that you can access it securely. And then next we go to the data cleaning part where we only I selected relevant columns for machine learning model like temperature and a temperature, like the feel like temperature, not the original one, and humidity, wind speed, and CNT represent the total bike rentals, and which is a target variable here. And I've cleaned the data and saved it with a new name, cleaned bike data.csv, so which will be used in for training the model and also in the beam pipeline. So next, coming to the model, so I've used I used scikit-learn to build a linear regression model. The features like temperature, feel like temperature, humidity, wind speed, they are used to predict the target CNT. which represent the total number of bike rentals. So after splitting the training and testing data into 80 is to 20, we train the model and save it using joblib. So this package is usually used to save and load the model. So as we can see, the model is trained and saved as bike model.pickle. On the left hand side, we can see all the files. And then as I got some errors, so what I did is uh, a mismatch between pickle and joblib. Suppose we save a model with pickle and load it with joblib, or save with joblib and load it with pickle, we get a class mismatch error. So I made sure the joblib is used consistently and for saving and loading as well. So now I got a class sklearn linear model based linear regression. Earlier I got some numpy array, so which is not correct. So I use joblib so that I get the correct model class and used a sample prediction to check if it is correct, and it's correct. And now we start with setting up the Apache-beam pipeline. And for that first, we need to define a model handler. And what this model handler does is it loads, it takes the model's URI as the input, and it ensures the model is loaded correctly. So we give the model link, the place where the model resides, and model file type, which is model file type dot joblib. We made sure it is in the type of joblib. And then I used a composite transform called a pre-processing data transform. This uh, the entire data pre-processing logic is encapsulated into this transform. So what it does is it takes each row of the CSV file, it parses it and it converts into NumPy array. So why we are converting it to NumPy array? Because we need it for the model inference. The data in CSV rows must be in NumPy arrays, so we do that. So the convert to NumPy array, what it does is this is a doFn which is used inside a Pardo. Uh, converts the each row of the data set into a NumPy array which we need, and and of course these arrays are the inputs for the linear regression model during the inference. And now I've defined a function for uploading it to S3, uploading the predictions to S3. So the upload predictions to S3 are the class here, doFn. It handles the collecting predictions during the Bream pipeline. Once all predictions are processed, then they are uh, written to a file, predictions.txt, and then uploaded to S3. So now we can see the last function, the complete pipeline function. We gave the bucket and file name and pipeline options. As we are executing in local environment, direct runner, and otherwise we can use a Google data flow or Flink, whatever. So as we are involving batch data processing, the streaming is set to false, and inside the beam.pipeline SP, what we did, we used beam IO, beam.io.read from text, which reads the CSV file, and on that CSV raw data, we apply the pre-processing data transform, and this composite transform we have already discussed. It converts all the CSV data rows into NumPy arrays. So we did that, we implemented that, and then on that pre-processed data, after converting the data into NumPy array, we are running the inference by passing the model handler. And the model handler also, we have defined here, model handler. A scalar model handler handles the model by taking the model location, model URI, and the type of the model, joblib. because we saved and loaded it as job lib. And after the inference has been done, basically on the same data set. So the predicted data, you're using a Pardo. So what it does is, we already created upload predictions to S3 doFn function. Here it is. I mean, sorry, class. So the Pardo takes this function, doFn function as input, and with the three parameters, it requires three parameters. So the bucket name and the file name. Sorry, two parameters, ignoring the self. The bucket name and the file name. The bucket name is HW Apache-beam DM, what I have created, and the file name I just created the predicted bike data. And if once running is just some warnings, we can ignore this. And the final output is, we can see that the file predictions.txt has been uploaded to S3 bucket HW Apache Beam DM as predicted bike data. So now we can just verify our predictions by, I mean, check our prediction data predictions in S3. So this is the S3, this is my S3 console. I've created a bucket HW Apache Beam DM, as you can see here. So when I ran that code, it automatically uploaded the predictions file to S3 bucket. So if you just open this, now we can see uh, the prediction result. So for example, array, I mean, these data points represent temperature, feel like temperature, humidity, and the wind speed. And the inference output, inference is 32119.0, that indicates that number of bike rentals, the CNT, basically, and the model ID, which model predicted it, our bike underscore model.pkl, which we saved and loaded. That model predicted this. So like this, we can use Apache Beam to run inference on our model by taking a sample data and store it to cloud storages like S3 or any other Google Cloud Storage for further analysis. So this is my demonstration. Thank you.